So that was the lecture, and now I got a few projects I want to demonstrate. And the first thing I want to do is talk about .NET, which we've talked about in CNET 126, but we're going to do it in a somewhat different way here in 127. Not for any very good reason, just I did this earlier using different tools. And I originally wrote this stuff for Server 2016, but today I checked it using a Flare VM. And you can do this on a Flare VM, but you do have to make the hard disk bigger, which is part of the optional instructions when you make a Flare VM. They make it with only a 40 gigabyte disk, and making it up to 80 is better. So you have to have Visual Studio 2019, which is big but not too hard to install if you have broadband. And I discovered today, by the way, that for some ungodly reason, what we're getting now is just a 30-day trial, but supposedly you can extend it longer by just creating a Microsoft account and signing in. I didn't check that. Anyway, so you have to install the .NET desktop environment. And .NET is Microsoft's competitor with Java. And it's really quite popular. In particular, the US military seems to love .NET. So .NET creates these objects that are partially compiled down to bytecode, as we're going to see, and then they run in a .NET environment, which exists, as far as I know, only on Windows. So it doesn't give you the interoperability of Java, and I don't know why people love it, but anyway, people do use it, and it's very handy for reverse engineers because it means, like Java, that the compiled object is very close to the source code, not like C, where it's down to an assembly language. So you can make this thing with Visual Studio. When you just launch something in Visual Studio, you have to tell it what type of object you're making. And here, you make a console application that can run on .NET Core. And so, when you create a new object there, it automatically creates the program for you. And this is object-oriented programming, so in fact there's a whole series of components you can in principle browse through, but all we're going to do is mess with the main routine here. So you have some boilerplate stuff, and down here it gives you Hello World. So it creates the classic Hello World program. And you can just run it. There's a run button up here. This will run it in the debugger, so you can see it go. So when you do that, it will compile, and you see messages go down the bottom as it compiles. And then it will run and print Hello World. And then it'll print a bunch of unimportant stuff here telling you that you're debugging it and so on. But that's how you can create code and run it in the Microsoft.NET environment. All right. And so then you can change the code to define a string variable, and then read from the console, and then echo back what you said. So this is a simple input-output program. So when you run that one, it will ask you what to say. And if you give it a really long string of A's, it will run and not crash, which is interesting, because if this had been normal C compiling, then you would have had to tell it how long the string was. And if the string was only 5 bytes long like this, then when you put in 40 or 50, it would crash. So .NET, like Java, like Visual Basic, is not as fragile as C. It's a higher level language, and apparently it's able to dynamically resize variables as needed. It doesn't crash just from putting a lot of data in a string. However, you can do that if you want to. You can have a more complicated program that actually uses stack allocation character 10, which is what you use to create an old-fashioned C character array that only has room for 10 characters. And then you can copy something into there in a way that will overflow the buffer. And you have to tell it that this is you're going to use unsafe program. You have to use special variable type to do this, because .NET doesn't normally let you use these unsafe variables. But if you wanted to use old-fashioned C code, you can put it in there, but .NET won't even compile it by default. What you have to do is go into the console properties and tell it to allow unsafe code, which is not the default. So, this is what I saw Dan Kaminsky recommend this for years. He said, rather than yelling at developers and telling them that they should learn all the stuff in this course and the other courses about all these vulnerabilities and be smart enough to avoid them, that is never going to work. What you should do is give them a development environment like Visual Studio and put defenses in the environment. So the developer doesn't need to know what an overflow is. They just need to do this. Well, yeah, you say it happens. See, let it happen. Well, yeah, but this is the way it always is. And the reason is the same thing, everything happens in Windows to support legacy code. Suppose you have some really old code that you need to use and you don't want to rewrite it in a more modern language. That's why you would do this. And of course, there's some risk, but you have some all-important thing that somebody wrote and has been gone for 10 years and you're still using it. That's the reason why. Anyway, so this is how you do, and then of course, if you do that, then it will crash. Then you'll get a funny error message and stuff saying it has crashed. So you can still have an overflow. .NET does allow you to have old-fashioned compiled C with all the vulnerabilities, but it doesn't make it easy. It makes it so that if you're developing a new application, it's not going to happen. And you can make graphical applications, and the reason I put this here is because we're going to look at this thing in the next project. So you can create a Windows form, .NET, and when you do, a Windows form gives you a little blank graphic object, and you can now bring up a toolbox and drag things into there. So you can drag in a label, and drag in a text box, and drag in a button, and put labels on them. And now these are objects that you can see, and each object has code. If you double click it, you can put code on it. So you can have a password, and then a field to type something in, and then an enter button. And when you double click the enter button, you can put in code. And so you can put in this code. If the text box is top secret, you win, otherwise you fail. So this is the only code you put in. This is all the code that the Microsoft development environment put in for you. And now you've made a little guessing game, but it's graphical. And so if you can run this, it'll pop up, and when you put in the wrong password, it says fail. And when you put in the right password, it says win. So this is the graphical version of the console guessing game that we played with in the past. So that's the game. Now, if you want to find the executable, you have to go in this window, and it is in a horrible place. Your home directory, source, repos, the name of your app, a couple of times bin debug, but it did create the executable, and you can copy it out of there and take it to another machine and such. So anyway, this is how you create a very simple executable, a .NET executable, using Microsoft's tools. And the next thing we're going to do is play with it and learn how to read the contents of this. So I think I can probably do this one live. So I made an app which is just a copy of that same thing, ED331. So I've got it here. I downloaded it on this machine. So I go on my downloads. And here it is, ED331. So when I double click that, it pops up a box. It asks me for a password. If I put in A, it says fail. If I put in top secret, it says win. So it doesn't do much of anything, but it does run. And all right. And so we want to see how that app is constructed in .NET. So we're going to use this thing called .NET Reflector, which is one of the tools you can use for this. So if I open .NET Reflector, which is just downloaded and installed on here, then here's this funny looking thing, and it remembers my old stuff here. So I'm going to try and remove this old stuff if I can. Decompile, export. Yeah, I think I've seen this happen before. I don't quite know how to remove old objects. I don't think I remembered how to put it in there. So once you've done something, it's kind of hard to do it again. What happens if I close this? Yeah. How about if I go to new? There's no new. Collapse all assemblies. Well, I'm going to try opening again. File open. Open assembly is what you do. And then you open your program. And it opens it. And what happens is you have all these system things which are the .NET functions. Now, if you were running Java code, it would have to run in a Java virtual machine. And when you're running .NET code, it has to have all these system routines, which are the Microsoft software that supports it. And the thing I've made is this Windows Form App 5. That's the name of it. So it appears here, and it's all collapsed. So it will appear when you open it, and now you have to expand it. And when you expand it, there we are, you'll see resources and Windows Form App, and you can expand that, and then references, and then system Windows Form. I think I've fallen off the track. So let me get my example here. Okay, you got to go Windows Form App, reference, not references, go into Windows Form App 5. Okay, it is easy to get lost in here, but if you've been doing the Android course, you'll recognize this all is very, very much the same process when you open up compiled Java apps. It's the same structure. It's obviously Microsoft's clone of Java. So you've got Windows Form App 5, and I got Form 1 here, which is where I want to be. And then I want to find Button 1 and Click Object, which is here. Okay, so I finally made it to the button, to code attached to the button in my Windows Form App, which is a little bit hard to dig down to, but there it is, there. And now over here, I have readable code that just says if the text equals top secret, win, else fail. And that's the point. So if you have a guessing game, notice I did not have to go into IDA debug, IDA decompiler, or GIDRA or anything. This is the code, the source code in a readable language is just right there in your .NET app. It's really more like just running an interpreted language than it is like running a compiled language. And here's something kind of mind-blowing. This is C# code. You can choose other languages. I could read it in Visual Basic if I want, and it will show me Visual Basic code. Now think of some other language that can do that. So the .NET object is compiled down to this bytecode stuff, and it can be decompiled back into any high-level language you want, and you get everything, including the names of the variables and everything. So you might wonder what the native language is. And the native language is this stuff called IL, called instruction language or something. And this is mighty weird stuff. Let me see if I can make the text bigger. I'm kind of afraid I can't. Nope. But anyway, I think I'll take my canned instructions and show you. This is the fundamental IL code. And here it is a little bit bigger. So the point here is, notice how they're different sizes. This one is 1 byte, 1 byte, 1 byte. This is all the way from 2 to 7. These are the fundamental languages of .NET. This IL code is partially compiled code into this sort of assembly language looking language, which is the .NET fundamental language. And down here is the part that will store something, load something, and then do branch if false, and then win, load string win. So this is the if statement that compares the thing you typed to the string top secret. This branch false is what will only show you win if you gave it the right number and show you fail otherwise. So if I could change this branch false to branch true, I would make a game where I always win as long as I put in the wrong password, which is an easier game. So here are the hexadecimal codes for these things. And you can just look them up on Wikipedia. There's a list of the machine language instructions in this IL language. I'm not sure, you're not supposed to call it machine language. In Java, you call it bytecode. I don't really know what the right word is for Microsoft.NET compiled code. But the CIL instructions exist here. So you can find that branch true is 2D. And branch false is 2C. So I just need to find the 2C and change it to 2D in a hex editor. And I can find it by looking at what's around it. So I have A6, 2C, then I'm not quite sure what, then a 72. So I can find that pattern. And here it is. It's not very far down. The A6, 2C, and then a skip one and a 72. This is the bytecode. So all I have to do is change that 2C to 2D in a hex editor. And I have now modified the bytecode so that this program will run. And that's what I've got here. I've done that here. That's this win, e33one._win. When I run this one, if I give it an A, I win. And by the way, if I give it a top secret, then I fail. So I've reversed it. So this is very much the analogy of the thing we did long ago where we had a simple guessing game and we modified it in Ollie debug so we could win more often. This is what it looks like. It is much, much easier to modify .NET code than it is to modify compiled C code. You don't really have to read assembly language. You just have to read, if you just want to look at it, you can view it in a high-level language like Visual Basic or C#. And if you want to modify it, you have to use this goofy language here, this IL language, which is a lot like assembly code, but simpler. Anyway, so that's the joy here, and I have a series of these to try. Games that are more and more difficult, and you have to figure them out. Can you change the branch to a NOP? Yes, I'm sure you could. Yes, I didn't do that, but yes, I'm sure you could either use a NOP or you could find some operation that does nothing important. I'm sure you could. You could also just read the code and find the flag, of course, by seeing what message would be printed if you did win. Like I say, you don't even really need to modify it to win. You could just stop up here where you're reading high-level language. But anyway, so there's a few of these crack-me's to try here where you have to read .NET code. And so that's kind of fun. Like I say, .NET really matters. For some reason, the military loves it. I'm not quite sure what the advantage of .NET is. I guess it must be easier to write the code or something. But anyway, as you can see, it spares you from having buffer overflows, and it may have other advantages. So anyway, that's what I wanted to show you there.